Hello, my name is Prathamesh and today I've done the project of deep learning for comment toxicity detection. This project built an AI-powered system to automatically detect toxic comments in online platforms using machine learning. The goal was to reduce manual moderation effects while improving the platform safety and user experience. The key achievement that I've got is best model that is XGBoost, outperform logistic regression and random forest. The business impact is that the automates 90% of moderation, cutting costs by 80% while catching 90% of toxic comments. Features used is combined text, that is PDF, IDF plus numerator features, that is sentiments, word density, toxic word ratio, etc. Deployment ready, saved as pixel files, which will seem like demo for real-time prediction. Why it matters? Because the safer platform, reduce toxic content by 15 to 20% compared to manual moderation. Better UX, 90% of precision, minimal false positivity, wrong place comment, etc. Third, scalable. Process 10,000 plus comment sections for large platforms. The tech stack that I've used is Python, XGBoost, Skitlearn, Streamlit, and SHTP for explainability. I provided the GitHub link over here. Uh, First, knowing the data input library, dataset. Mm, Moving on to charts. So, I've totally made the 10 charts. Going to chart number 1, this is the comment line distribution. This shows that the distribution of the comment line. It helps identify if toxic comments tends to be longer, shorter, or non-toxic ones, guiding future engineering for lens-based thresholds. The second chart is word count per comment. This plots the number of words in each comment, reveals whether the toxic comment uses more or less words, which can be predictive feature for toxicity classification. The third one is toxic versus non-toxic comment length. This compares the average length of toxic and non-toxic comments. Highlights statistical difference. Example, toxic comments will be longer due to ranks for feature selection. The fourth one is word cloud for toxic comments. This visualizes the most frequently word in toxic comments. Quickly identifies common flaws, insults, or aggressive terms that drive toxicity prediction. Now, the chart number 5. The word cloud for non-toxic comments. This shows the frequently words in non-toxic comments. Helps contact positive neutral language against toxic terms, aiding for in future importance analysis. The sixth one is sentiment distribution. Plot sentiment polarity sense negative to positive for comments. Toxic comments typically cluster in negative sentiments, range validating sentiments as a usual feature. So chart number 7 is toxicity by sentiment. Compare sentiment scores between toxic and non-toxic comments. Confirm that the negative sentiments strongly correlate with toxicity, supports its inclusion in the model. Going on to chart number 8, toxic word ratio distribution. This shows the ratio of the toxic words per comment. Toxic comments have higher ratios than making this a powerful prediction feature. Chart number 9 is class distribution, toxic or non-toxic. The bar chart showing the proportion of toxic versus non-toxic comments reveals class imbalance. The example 10% toxic, 90% non-toxic. Actually, techniques like class weighting. The last one is correlation heat map. Displays correlation between features, helps identify multi-polarity and the strongest prediction of toxicity for feature selection. Why this chapter matters? These visualization guides feature engineering and model selection. They ensure the model evaluates the most predictive and interpretable signals for toxicity detection. The next is hypothetical testing. The first is if there is no difference in the length of toxic and non-toxic comment, the significant difference between mean and non-toxic and non-toxic comment. Hypothesis 2 and then hypothesis 3. The box plot for the word count and everything box plot. Data scaling. Moving on to the ML model implementation. So the first model that is implemented is logistic regression. This linear model for binary classification uses sigmoid activation to predict toxicity probability. Interpretable, but struggle with complex non-linear patterns in text data. The baseline with it is a baseline with faster training but lower performance than tree-based methods. The evaluation for it and the cross-validation hypertraining model. Model 2 is a random forest. It resembles the decision tree that votes for the final prediction, handling nonlinear relationships well. The robust two outfits and provide feature importance of slower than exhibit. It is a moderate performance model with F1 as 0.91, but with better recall than logistic regression but higher computational cost. Moving on to the third model. This is the exhibit final model. Gradient boosted with regularization, optimized for speed and performance via parallel processing, handles imbalanced data naturally, and provides steps for values for explainability. Best performance like F1 at 0.92 and accuracy at 0.95. It's calibrating for real-time moderation. This is a model that I've used for deployment. Saving the model using Droplet and using Streamlit and deploy the model. Now I'll just deploy the model. Now these are web models using Streamlit that I have done. So Doxity data snap. If you put the comment below, so I put the comment of this sample comment. So it shows the non-toxic with the percentage of 0.34. This comment appears to be normal. And the next, if I put toxic comment, it will show a toxicity of 0. Sorry, it will show a toxicity of 0.81, which is really toxic. And the confidence level, toxic confidence level is 81.34. So thank you. That's all for the project.